Hello students, today I am going to teach you the most important equation and chemical structures about the chemistry, and it is related to the class 12th as well as JE and NEET students. Okay, so here we see the questions. So what's written in the question? First of all, the question is related to the anhydride 5-membered ring. So we have to make the 5-membered ring, students. Okay, so this is the our logic, this is our answer. And after being solved this, so such type of equation will be emerged out, students. Okay, but I'll teach you everything by a single step and everything step by steps to you, students. So here we see, first let me erase this, then I'll tell you. And this equation is used to make the pens and electrical cables and so many parts. So here it is asked, we have to make the anhydride, means phthalic anhydride 5-membered ring. So what we'll do, students, first of all, we'll use the C6 and H6 for this, because the starting material is based on the benzene ring, students, and the standard benzene ring always has the standard formula of C6 and H6. So we'll start from the C6H6. C6H6. Here I'll also make the structure, students. Here it is looking like the hexagon. Means, students, it has the carbon atoms. It has the 6 carbon atoms arranged in this benzene ring with 1 hydrogen atom attached to each carbon. Okay, students. So we can see 1, 2, 3, 4, 5, 6. So 6 carbon atoms, and it also already contains the 6 hydrogen. 1, 2, 3, 4, 5, and 6 hydrogen, students. Okay. So and attach, we'll also attach the 2 carboxylic acid. COO. But students, please remember that we must remove the 2 hydrogen. We must remove the 2 hydrogen from this benzene ring to make room for the carboxylic acid group, students. Okay, so 2 hydrogen will be removed to make a room like this. Now it will become the dicarboxylic acid groups. Okay, students. So here we have written. Now what we'll do are in equation. First of all, plus COOH. Now half of our equation is ready, students. Reactant is ready. Now what we'll do? The heating process, students. Okay, we'll start the heating process, and a minimum 200 degrees Celsius. It must be as from the between the 190 degrees Celsius to the 200 degrees Celsius according to the laboratory, students. So laboratory rules, students. Okay, so here the heating process starts from here, as this is the sign of the heating process. 200 degrees Celsius. Okay, students. 200 degrees Celsius. And what will be happened in during the heating process? In the heating process, we must remove a molecule of water, H2O. During the heating process, a molecule of water, H2O, is removed from the carboxylic acid groups. Okay, students. So here this is that you can see 2 hydrogen and 1 oxygen. So 1 hydrogen and 1 oxygen will be removed from the upper side, means top side will be removed, and 1 hydrogen will be bottom side from the carboxylic groups. Okay, students. So here we see it will become the H2O. Here also I write the H2O. This is the equations and this is the structures, students. Okay. So what will happen if we remove, means during the process, during the process, means a molecule of H2O, okay, is removed to create a 5-membered anhydride phthalic rings. Okay, students. So here same to same it will come here, because so these structures will be made by us like the hexagon. Now I have made this, and 5-membered ring. How it will make? Because as we know that 1 oxygen and hydrogen, means H2O, has been removed from here, and in the form of the steam, because it has been evaporated. During the evaporations, it has been removed. Okay, students. So what will 5-membered? It is said the 5-membered. So let me count this. 1, 2, 3, 4, 5 means 3 oxygen and 2 carbons we will find. So with the help of the 3 oxygen and 2 carbon, we'll make the 5-membered ring, students. Okay, so here we see that I'll transfer from this, and we'll also write this one same to same. So students, please remember, we have forgotten to this. If we transfer, if we give the 2 hydrogen to make the carboxylic acid group, so it will become the H4 like this, students. Please don't forget it. It is very important for you. Okay. So now what we'll do, the students? C 1 O means C is equal to O. Here C O, and at last we'll do the oxygen. It will become like this. Means CO and O will make here like this. Okay, students. And at last what we'll see, because it is we have to also complete this equation also, students. So what we'll do? First of all, C6H4. See, it will become the minus because water has been removed by us. Students, don't forget it. Now C6H4 plus. Now students, C6H4 and then CO2 and O plus H2O. This is right equation. Okay. So here I made the C6H4 CO2 O plus H2O. So then students, this is called the benzene ring. What should I write here? I also want to write the BENZENE, benzene ring. This is called the benzene ring, this one, this hexagon. And this is also called the benzene ring, students. Okay. And this is called the 5-membered anhydride ring. Means phthalic acid, phthalic anhydride. So PHTHALIC, phthalic. PHTHL is phthalic anhydride. Should I write, because there is some short of the space here. Anhydride. Phthalic anhydride. And this is called the phthalic acid. This structure is called the phthalic acid. PHTHALIC, phthalic acid. So during the heating process, it will become like this, student. And I just want to explain you that C6H4 and hydrogen, it will become the CO2. So I have written the CO2, students. And what is it be remained? 1 oxygen, because H2 has been removed from here. H2 means double hydrogen, H2O. So this is the 2 oxygen, means 2 multiplied by 2 ones are 2. So this is the 2 oxygen. So 1 oxygen has been removed in the with the H2O. So 1 oxygen we find. So 1 oxygen will be sent there. So it is the 1 oxygen, students. Okay, this one. And many students used to ask me, sir, H2 has been means it has been vanished during the evaporations and as a steam. So why are you writing here? So we just write here to equalize this, to make it equilibrium. So we have to write in the equation this, because if we don't write, so we don't equalize the equation, students. Okay, so I write the H2O here, and here. So our now equation has been balanced, students. So if we want to make the balance, so we have to write the H2O here. Okay, students. So everything is okay. This is the logic. This is our answer. And many students ask to me, sir, what is this circle? What is called this? So this is called the aromatic ring. And this is means it is related to the pi electrons, students. And every pi electrons, it is shared, it is equally shared to each electrons. So this is called the pi electron. So it's called the aromatic ring, students. Okay, and we can also say the delocalized ring like this. So here is our logic, here is our answer, students. And if you want to, I'll also bring more and more videos like this, student. So please subscribe to my channel. Thank you for watching my video.